Yeah. Okay, so as you all know, this class I have reserved for your doubt clearance. If you have any doubt with the things we discussed so far in this dielectric chapter, please ask. Any topic you want me to uh, re- recapitulate? There is nothing else we are supposed to do in this class. Okay, that's why I want everyone to join as well. Rudonil, do you have any doubt in dielectrics?
Mm, No, so actually, I haven't started studying that yet, but I had some questions regarding dipoles, sir.
Yeah. What question?
So wait, I have to bring my other notebook.
Okay, okay,
Give
yeah.
me a minute, sir.
Okay. And revision classes won't help unless and until you study on your own at home, the same thing. Okay, so it's just recapitulating everything, isn't it? That is done with brevity. That is how revision classes are always done. However, I don't think I did like that. I described everything that was in your syllabus. Hmm. But usually, if you just go to an academy or anywhere else, you will see that revision classes are like just brief recapitulation of the theory and then some numerical problems. But I thought that since we are not appearing for any MCQ exam, we have descriptive paper exam, type exam, so I thought I should explain everything. Anyways, did you call your friends? Did you text them? Just tell them to attend this class. It's very important because
Yes,
after
sir.
this Diwali, Bhai people will tend to forget even more what they studied. Yeah, Anjali has joined.
So,
Yes.
sir, I sent a photo in WhatsApp, so I
Okay.
needed help to understand it, sir.
Let me check. Acha. So it's about the work done in rotating a dipole in uniform electrical. Yeah. What you want me to explain from here?
So I couldn't understand this. So that's all.
The situation is like this: that you have a dipole. Dipole, I think you know, two
Yes, sir.
charges would be there, separated by small distance, equal and opposite charges. So this dipole looks kind of this. Say minus q here, plus q here. They have a separation. The separation is not necessary in this diagram, so they haven't put any name to that. I can call it say L. So now this dipole, I want to rotate it. Now, how can I rotate anything? Rotation can be achieved,
Clockwise and anti-clockwise.
right? That is called the direction. And if I say that what is the mechanism of rotating, one thing can be done. If I fix one end and suppose this end is fixed, I'm before that kind of like I've drilled it by a screw, and if something is blowing, wind is blowing, it will go like this. That is, it will have a tendency of rotating, provided this thing doesn't move. Another thing is what? Application of couple, that is equal and opposite forces. Say like this. So this second thing is going to happen here if I throw this dipole in an uniform field. What is uniform field? Fields are always visualized in terms of their field lines. You can see the lines are equispaced and the direction is from left to right. That is, if you put a positive charge here, unit positive charge, it will flow from here to here. So now I have just thrown it. Thrown it means I have just put the dipole here at any random orientation. That is, it is making some angle say theta with the field lines. with the direction of the field lines. Okay,
Okay, sir.
so charges are opposite. That means the force that this charge will experience, if it experiences from left to right, it will definitely experience from right to left. We know that field lines means what? The direction in which the positive charges will move. That is, this charge will have a tendency to move along this direction. Did you get it?
Yes, sir.
Had this charge been alone, only isolated as a plus q charge, it would have moved this way. And we know that force is equal to charge into electric field. That is the definition of electric field. Force on a unit positive charge. So force is equals to charge into that. And had there been only a minus q charge alone, it would have moved in the opposite direction. So it has a tendency to move along that direction. That is, it would try to move that way. Just hold on. Yeah. So did you get it, Buddhani? What is the situation?
Yes, sir. Yes, sir.
But neither of them can move in that way or that way alone, isn't it? They are bounded together. So as a whole, what is happening? This is having experiencing a force along this direction. It is experiencing a force in this direction. They're equal in magnitude, opposite in sign. So what will happen? It will try to rotate it in clockwise direction. Fine. So now it has to do some work to do this. And in rotation, we don't call force. We call something as torque, which is the moment of force. That is, torque is equals to R cross F, but in this case, I can write it as P cross E, where P is the dipole moment. And P is directed from negative charge to positive charge. Or positive to negative. What is the direction of dipole moment? Anyone?
So negative to positive, if I'm so negative to positive.
Negative to positive, okay. Yes. So the P vector is deducted from along this direction. Okay, so that is the torque. I need the magnitude of this. How this expression comes, you have to revise your electrostatic chapter. Sine theta, that is how cross product is done. And you can see that P, I said what is the direction of P? P vector is like this. So it is a P vector, this vector is P, and E vector is along this direction, so the angle is theta. So we have P sine theta. Now what is the infinitesimal work done if I want to rotate this dipole by a small angle, infinitesimal angle, so d theta? That work done would be equal to tau d theta. Okay, you can draw the analogy that work done in Newtonian or linear mechanics is like f dx kind of, or f ds, whatever. Okay, you can say that here torque plays the role of that of force and d theta plays the role of that of displacement. But remember that torque is not exactly force. Okay, you can draw analogy, but it's much more than that. So what is the total work done? Suppose initially it was making an angle theta 1, at the end you want it to make an angle theta 2. So I have to integrate between limits theta 1, theta 2, tau dt. And if you integrate cos sine, you will get minus cos. So ultimately you would be getting this. Got it?
Okay, sir. Okay, sir.
Okay. Okay, then anyone else is having any doubt? Others, anything you want to repeat or want to know better?
I'm thinking, sir.
Hmm?
I'm thinking, sir.
Okay. Aryanjali, anything else? Anything you want to, you want, I mean, you have any doubt regarding anything? Aryanjali, Shravan, okay, no doubt. Shravan,
So, can I suggest one thing?
yes.
So, if we have no doubts, then we can solve papers,
Paper means a numerical problem or previous year paper?
previous year papers.
That's a very good suggestion, but you have to provide me with that because I had kept that in my mobile phone, and that phone has gone out of order. So if you have some previous year question, that would be very good.
So, I have some jam questions, but
Yeah, that also we may solve.
so then can I send it in WhatsApp?
Yeah, you may.
Okay,
Yeah,
sir.
Shravan, that is very difficult because you have to first know that at what rate the field is changing. Okay, and that is difficult because at when you are trying to study at a particular instant of time, you need to know exactly where the field lines are directed. Hmm. And that won't give us any important result. I mean, that is a very general thing that when field lines are changing, that is for the non-uniform case. Okay. I mean, you're asking if the field is non-uniform or if or what? Yes, Shravan, I couldn't get you.
I meant so field lines keep on
Hmm.
changing it,
Hmm.
keep on changing the field
Hmm.
lines in a
Huh.
clockwise manner. So
Okay.
will the dipole keep on rotating, sir?
Yeah, yeah, yeah. It will always have a
Or will it
tendency,
cause some?
definitely. Like
Oh, okay,
the
sir.
equilibrium would be what? The equilibrium situation would be when the dipole is parallel to the electric field lines, isn't it? That is the equilibrium situation. Hmm. You can think
Yes,
it
sir.
like the flow of water, a stream. If there is a change in the path of flow, I mean, not path, if there is some mm, change in the lines of flow, definitely if you drop any light particle, you will see that's evident by its motion. However, we restrict ourselves to the uniform case. Yeah, Rudon is sending. Let's see if I will see whether that jam question is relevant in context of your upcoming exam? If yes, then we'll solve. We can solve. Has anyone ever seen any class in Unacademy? Anyone?
No, sir.
Hmm.
Yes, sir.
You can go to YouTube. You can see there. They are actually, the students are not supposed to. You can't share your screen or speak. There's only the chat box, and if any of your comments are not appropriate, I mean not only appropriate, but if you are endorsing any other brand or anything else, there are many criteria. I sometimes attend unacademy classes for some reason, and whenever you first begin to type your question on the chat box, that pop-up comes that please maintain the decorum of this class, avoid using or avoid communicating via these things. If you are found, then you will be expelled from the course. That is one thing. And Unacademy, there these type of classes are very very frequent, where you are given the chance to clear your doubts. You can see that, okay. Then you can suggest if we can uh, change anything in our way of teaching or the classes. Okay, Rudonil, which year's jam question this is?
Sir, 29,919.
Oh, okay, okay. Is this any Aryan Publications book?
Yes, sir. Yes, sir.
Yeah, they all have same type of this font.
So, will I send the
Yes.
answers also?
Yeah, that would be better. I won't try to be a hero by pretending that I know all the answers are correct, because the MCQs are not like that. Okay, definitely.
All right, sir.
And we'll not see the answer initially. Keep it for a reference. MCQ questions are not like that. At the end of the day, you have to see whether the answer is correct or not. And whoever is trying to appear for jam in the coming days, first thing you will do, I told you also before one day in one class, that solve all the previous year questions first, at least the previous 10-year questions. If your exam is not that old, I mean, if this exam has been is being conducted since the last 3 decades, that is absurd to do the last 30 years question. If you have last 15 years question, that is also possible to be done in MCQ form. Else last 10 years question would be enough. Okay, now we have to find. Let me do one thing. I can share the screen. That would help, I guess. Again, it is on WhatsApp, and that my school group is also very active today. Just a minute. Let me present the screen so that
So, you
everyone
can
can
mute
at
them
least. Still, that would come, na. I mean, how long can I mute them?
8 hours. You can
I
unmute
mean,
them, sir, after the class.
oh, acha, acha, acha. Oh, that's a good idea. Then I can do, because after 10 years I got connected with many of my friends. So okay, that's a good suggestion. 8 hours. Okay. So can you see my screen, everyone?
Yes, sir.
Okay. So question number 1 is from mathematical physics. Question number 2 is from quantum.
It's a
Not.
classical, sir, not quantum.
Oh, class. Is it classical? Classical
Yes, sir.
vertical. Oh,
Total
acha,
energy
acha.
and potential
Oh,
energy.
sorry, sorry. Then that's central force kind of thing. I don't know. Number 12. Very easy. Do you know how to calculate eigenvalues?
Yes, sir.
How?
Vikramji sir taught. Sir, I think so. Lambda into that 100,010,001 that matrix into lambda.
Hmm.
that matrix into lambda
Hmm.
is equal to means. So how do I say it?
It is
We'll
like
take
a minus lambda equal to 0.
yes, yes, yes.
Yeah, secular equation, right? That is true. But I have another trick only for this exam. Okay, if you apply this trick in your CBCS exam, you won't don't get surprised if you get 0. You won't get, but it's highly probable. You see what is the order of this matrix? 3 by 3.
Yes, so
So you know what are the number of eigenvalues that I can expect? 3. Do you know
mm.
what do you mean by trace of a matrix? Trace,
So can you put can you like I can't see the question, sir.
is it?
So a little bit up. Yes, I can see now. I can see now.
Acha, acha. Just hold on. I have to...
No, sir, no, sir. It's okay. It's okay. It's okay.
Okay. So, do you know what is a trace of a matrix?
No, sir.
Acha. These things are bit, I mean, higher level theory on matrices. Trace means addition of the diagonal terms, sum of the diagonal. What do you mean by diagonal term? 1, 1, 2, 2, 3, 3. These are called the diagonal terms. Like A11, A12, A13. So the terms whose row number and column number is same. It is first row, first column, second row, second column, third row, third column. Okay. So if you take sum of these diagonal elements, that is called trace of the matrix. So what is the sum here? 12. Okay.
Okay, sir.
And when you will do the theory in details, sum of the eigenvalues is equals to trace of the matrix. That is lambda 1 plus lambda 2 plus lambda 3 will be equal to 3 plus 3 plus 6, that is 12. And the determinant of this matrix is equal to the product of all the eigenvalues. That is lambda 1, lambda 2, lambda 3 is equal to determinant of the matrix lambda 1, lambda 2, lambda 1 plus lambda 2 plus lambda 3 is equal to trace of the matrix. Now you check the options. There are
We
4
did that.
options. You did na?
We did this way only, sir.
Acha, acha. Now you can check. At least I think one option is always given. Most of the times is given incorrect. Or maybe not. Okay. So, but if there are complex elements like C here, there is I, then it is always wise to do it in details. Okay. A minus I lambda kind of thing. Otherwise, if you are given a 2 by 2 matrix, they won't ask you to find the eigenvalues of 2 by 2 matrix at all at this level. Suppose this matrix had all entries as real numbers, then you would have done like that. Okay, that's a shortcut. Number 13 is quantum. Number 14 is classical. 15 is what is it? It is, I think, electromagnetic theory, light. 16 you can do. I think we did this in one class or something like this. I hope everyone can do number 16. Can you see number 16?
Yes, sir.
Yes, sir. We can do it, sir.
Yeah, that can be done. I am sharing the screen, but I am unable to see how it is looking like. Anyways, if people can see, that is enough. Dead star, black body radiation. Okay. Mass per unit length of a rod is this. These are rotational dynamics, moment of inertia. You have to calculate that. Di equals to r squared, x squared dm. That formula. Number 19 is for analog electronics. That amount of work done using relativistic mechanics, solid state physics. This one is quantum mechanics. Is it Compton
S-
sketch?
Sir, can you zoom out a bit? We can only see half question.
Now,
So we can see the left side of the
I can
centralized.
see,
So
I can
just keep
see,
the
can't see on my phone as well.
so like
Just
just keep the full size, and we
it's
can
okay,
zoom
sir.
it from our side, sir.
Yes, so that.
No, no, I am sharing my screen. How can I take it to your side or other side? Oh, like
So what he
this.
meant was
I
like
can
just
go.
put the whole
I
screen.
can.
We'll zoom it.
We can zoom it from our end, sir.
Oh, acha, acha,
Like
acha.
from our
Is
screen.
it available on WhatsApp?
Yes, sir.
So in meet,
Just hold on. I mean, what is wrong with my Meet? I can't see my presentation on my camera, mobile phone. I understand something is wrong. Just a minute. Let me stop the recording. I mean the presentation. Restart my entire screen. Why can't I see my presentation here? Can you see now?
Yes, sir. Yes, sir.
Yes, sir.
So 21 solid state physics, 22 is again quantum, 23 is thermodynamics, climatic condition. So not what we're looking for has come here. Not that thing. Um, let's see whether this page we have. Number 24 is triple point two. Solid state, thermodynamics, statistical mechanics, thermodynamics. 25 is, it's a common thing you can find it in electromagnetic theory. 26 CIO diffraction, Fraunhofer diffraction. The maximum number of intensity maxima that observed.
So I can do one thing, sir. I can send it in the group. Everybody can see
Yeah,
it.
that
Like,
also you can do. You people yourself can go on checking. That is also good. It's not a bad idea. The thing is that let's see if we have anything from dipole thing or not. Okay, you people share it. No problem. Scalar field. This portion is very difficult to be done. This MSQ. Okay. Very difficult, and it is where your real knowledge is tested.
so which part, sir?
MSQ, multiple select questions, where the
Oh,
topics may have more than this one. They may have more than one correct option. And I'm telling everyone that in the exam, this NAT, numerical answer type questions, they don't have any negative marking. That is, if you do them incorrect, you won't get the marks that we are supposed to get. If it was worth one, you won't get one. But there are other questions where, suppose you have a 2 mark question. If you make that incorrect, you won't get two. Over and above that, you would get 1/3 of two. That is 2/3 less. So if you get a 2 marks question correct, you are supposed to get 2 marks. If you get that incorrect, you are supposed to get -2 with 1/3 of that. I think you know the negative marking scheme. You know everyone.
yes, I know negative marking, sir. Not the scheme.
yes,
Scheme means in some exam only 1/4 of the marks is deducted as negative marking. In some exam 1/3 of that. I think 1/3 is in this GM. And this NAT questions, I think they don't have any negative mark.
Yes, sir. Yes.
So whenever you will see in any exam, any question doesn't have any negative marking, blindly attempt them. Blindly means just try it. If out of these 10 questions, if you get 2 correct, that may be a bonus. But where you have this negative marking thing, be very cautious. Like here. Okay, number 1 is chemistry. What is it? Oh, radioactivity. Sorry, radioactive activity. Sodium, BCC, solid state physics. This is about your grading. Number of lines per unit length, 4000. Mean free path thing, mean free path, and molecular diameter. Have you done that chapter in kinetic theory, mean free path thing in the first chapter? Have you done it?
Yes, sir.
There are 3 treatment. One is the treatment where we are assuming that only your molecule is moving, rest are frozen. Second one is the Clausius treatment. Third one is the Maxwellian treatment. The results will come like this: lambda, the mean free path, is equals to 1 by pi sigma square n, 1 by root 2 pi sigma square n, then 3 by 4 pi sigma square n. Whatever it is, always it is proportional to sigma square n, sigma square, I think. So sigma is the molecular diameter.
So,
Yes,
question number 47, sir.
47. Okay, you are on the next page. Let's see. 47. The electrostatic energy in units of this is uniform. So electrostatic energy, that is half CV square of a uniformly charged spherical shell of total charge.
So we can
Yeah,
do this question.
yeah, very good. Now tell me, should I use half CV square here or something else?
So half CV square.
Where is V? First, I always taught you that whenever you're doing any problem in physics, first write what is given.
Yes,
What
sir.
is given here?
Charge
Yeah,
and
and
radius.
yeah. So Q is given. And try to identify the system. It is SI system. What do you mean by in units? That means in units of 1 by 4 epsilon 0. Achha. Okay, you first calculate it. Then we can see.
So V we can replace now. So,
Yes.
so V we can replace now by C and Q.
V, I mean, why should we do that thing? Because, yeah, that can be done. But why should we work hard when we have an option? Can you see my screen, everyone? I mean, my copy?
Yes.
Sir, V is, so it's a uniformly charged spherical shell. So V will be 1 by 4 pi epsilon naught, 5 by 4 meter.
Yeah. But I can, what is my formula?
Half CV
Half
square.
CV square. But if I know Q and C, then also I can write it. No, what was the formula initially?
Mm,
This thing, isn't it?
yes, sir.
This was my formula. So now I have Q and apparently I don't have C. Okay, but for a uniformly charged sphere, what we saw, and see there is no mention of any other sphere around or shell. That means it is the case of isolated sphere. And this is the formula where A is the radius of the sphere, isn't it?
Yes, sir.
The only thing you have to do, you have to convert. I think what is the radius, Rudhanil? How much centimeter?
4 cent, 4
Convert that
meter.
into meter.
4 meter, sir. 4
To
meter.
4 meter. Meter or centimeter?
Meter, sir. Meter.
Is it meter?
Yes, sir.
Wait. Oh, then task is even easier. Task is more easy. Okay. So that's your capacitance. It's an MCQ question. Okay. And in MCQ question, your rough work should be minimal. I can give you some example of some rough work.
So it's a numerical type question, sir.
Yes, but In the exam is MCQ, na? You're not supposed to write everything on paper in details.
Okay, sir.
Okay. So you have to. This is I practice rough work like this that you won't understand what the question means. So I had to check 3-4 matrices. So see, I have done only the calculation, but I haven't written anything that any literature is not written there. Just have to do the calculation, the rough work. It has to be done as minimal as possible. Okay. So like here, I'll just quickly write that C is this. So what would be Q? W. Q is how much? How many coulomb? 5 coulomb, na?
Yes, sir.
So 25 Q square by 2 into this thing. And IIT questions are a bit student friendly. They don't want everything in details. What did they ask in units of what? Units of 1
1 by
by
4 pi epsilon naught J.
1 by 4 by epsilon naught. Okay. 1 by 4 by epsilon naught joule. Okay, yeah, definitely it would be joule only. Energy. Mm, so 1 by 4 by epsilon 0, except that whatever it is, you just divide. And what they have said, you have to round up to 2 decimal place or what?
Yes, sir.
Okay, do it. It is possible to round off. So Rudon, you have to check the answer. Okay, I think it should be 3.12. Can you check the answer?
Yes, sir.
Oh, I also have it. Let's see. Soft number 47. How many decimal places did they ask?
2, sir.
2. Yeah. Is my division correct?
Yes, sir. The
Did
answer
I
is
make
3112.
1, 2? Yeah. So see, what they asked that your answer in units of this, that is how many times it is of 1 by 4 by epsilon 0. That means suppose when you will do quantum mechanics, you will see that uh, if there is a particle in a 3-dimensional box or 1-dimensional box, the energy of in a state looks like this. Okay, this entire thing is constant. So many times they say in the exam, in units of this, what is the answer? That means don't put the value of this. You know this value is 9 into 10 to the power 9. I think you know 1 by 4 by epsilon 0 is equal to this. So what is your answer? Your answer is only 3.12. And in the exam, they give a range of answer for this NAT type. They may give it like this 3.12 to 3.13. That is, your answer should be either this, or anything between. So did you get the question? How to solve it?
Yes, sir.
Yes, sir.
Very
So is
simple. Yes.
Joule, no, sir. Unit.
What, my copy?
No, sir. Unit should be Joule, no, sir.
Hmm.
Oh,
So
Joule, Joule.
units,
Yeah, right. Unit is Joule. That is
sir,
given
but
in the
answer should be 3.12, no, sir.
3.1.
2.
Yeah, 3.12 is the answer. But I'm just
In
giving an example. There are some numerical problems where maybe it came like this. So up to 2 decimal place, someone can write 3.13. But here I got 3 point. Is my division correct? First check that. Is it correct? I think it's correct.
Yes, sir.
So when the answer key is published, there are few questions where the answer is exact, like some answer is 2 only. So there you have to put it in the, there's something called virtual calculator. That is, you will be giving this exam in the computer. Yep, there's a drop down box kind of thing on the topmost portion of the screen. There's something called virtual calculator. That is a calculator that we have in our laptop only. You have to do the calculations there only. Okay. So your answer is supposed to. When you are putting it, you can't write 2. You have to write 2.00 like that. Fine. And when the answer key is published, suppose they will give that the correct answer for this question is, it is 2 only. So the answer key will be written like this, 222. That means your answer should fall in this range. Suppose the answer of a question should be either 1.67 or 1.68. Okay, so they will say the correct answer should be in this range. Okay,
Okay, sir.
did you get it, Ruddonil?
Yes, sir.
Hmm. Anyways, the answer is correct. So you see, these questions are not difficult at all. You have to have very good knowledge of the underlying theory and how to apply it. It's not just mugging the formulas. Because if the same question was given in centimeter, many people would get confused. And many people would think like the formula of a sphere looks like this. Where is B? Isn't it? They would be confused. So both theory and your numerical problems are equally important. Okay, so one question is done. Do you have anything else? We have anything else? Let's see. Number 52 is a complex integration. 53 is atomic physics. Next is uncertainty and position. Acha. Quantum. 55 is quantum. 56 is Zener dead. Yeah, you can get it. You will be able to solve this in the next sem only. 55 gravitation. 58 is thermodynamics. 59, you can try 59. Try now. Try number 59.
Sir, I forgot, sir, how to do it.
Eh,
Sir,
how can
wait,
you
sir.
forget this?
I have to check my other copies.
Who is the goalkeeper of Juventus now?
Sir, this,
Hmm? Who is the most famous goalkeeper in Juventus history?
sir, I mean, sir, if I revise, I can get it,
No,
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 sir.
no. You tell me now. This is also a revision method.
Sir, Buffon, sir.
Yeah. Which team he represented? National team?
Sir, Italy, sir.
Italy. Okay. That means you love Buffon more than digital. Okay. That cannot be done. Anything cannot be done. That's your choice. Okay, now let us see. We won't open the copy. Let us see what we remember, if we can get any help from there. One,
I think it should be 110.111.
okay. Point triple one. I
No,
mean,
no,
you're
no, no,
telling
no,
the,
no, no, sir. 110.101.
I mean, the question is incorrect that you're telling. You can check the answer portion if you think that is incorrect. Let me check. No, it's correct. Answer portion is correct. Rudonil, I think you know how to convert 110 into decimal. This thing I think you remember.
Yes, sir. Yes, sir. The decimal parts is, I mean, after the point, I don't know, sir.
Okay. So tell me what is this thing equal to?
So 110.
Yeah, 110 is equal to how much in decimal?
So 1 into 2 square into 1 into
Hmm.
7,
Yeah,
4, 6. 6, sir.
6. Yeah. Uh, Having done so much of digital electronics over the past 3-4 months, you can easily tell what is the binary decimal of the binary up to 1111 if you remember the table. If we did anything, any 16-bit electronic device we studied. Okay, that's why I always told you to write the truth table in that perfect fashion, the 00000010010, because on the decimal side it runs serially like this. Okay, so this part you got correct. What about the decimal part? The decimal part is how much? 101. So in the decimal, what you have to do? This. Okay.
Okay, sir. So then we'll add the both or something. Or we'll
I
multiply it.
think I made a mistake. One, two. Sorry, it should be three. No, sorry. It should be three. I'm also thinking how quickly it is happening. 5/7. So it should be how much? 6 8s are 48. 48. So carry 2. 2 6 to the 16. Carry 4. 5 6 the 40. Yeah. So the answer is you have to add here. So on the decimal side, what it would be? Suppose it is like point A, B, C, D like this. It won't be A, B, C, D. It would be either 0 or 1 or combination of that. It would be like this. The digit next to the decimal, just next to the decimal, will have the weightage of 2 to the power minus 1. And the following will be having weightage of 2 to the power minus the next integer. C, D into 2 to the power minus 4 and so on. And on the right hand side, if you have E of G, this right hand side you know it would be G into 2 to the power 2 or 0 plus F into 2 to the power 1 plus E into 2 to the power 2. That is the general thing. You have to just add the two parts.
Okay, so
Okay, and remaining things, the last problem that is called magnetostatic boundary value problem. The same thing we did with electric field and electric displacement vector. Uh, Same thing is also there with that magnetic field and magnetic flux intensity B and H. I don't think that chapter is. Do you have it? It's in magnetism. If not in this sem, then you may have it in the coming semesters. Okay, you can
there's
see.
another
Yes.
question, sir. Question
Where
of
where
14.
40.
1 4.
Oh, 14. Did I miss it? Let me see. 14. 14. Acha, spherical ball having charge q mass m is held is tied to a Thin, massless, non-conducting string by an infinite. Sigma. Have you done that method of images in electrostatics?
No, so but we can do this by that now. Like we'll take out the vectors and then we'll put like
That also can be
perpendicular.
done. The field lines would be what we have. We have a string. I mean, what is that shaded thing? Is it a, yeah? It's a non-conducting sheet with uniform charge density sigma. Okay, so the field lines would be what is that expression for field lines? I think it's mm, this is the expression for the electric field. I think it would be outwards. Is it sigma by epsilon or sigma by 2 epsilon? The average field. Wait, let me check. Should be sigma by 2 epsilon, I think. Average and like this. What is happening with this thing? This thing is the ball is mm, at equilibrium. The string is making an angle 45 degree. Fine. To draw the picture, redraw it rather. -45 degree. You have to find sigma. This thing you have to find. This would be the mass is also there, charge is also there. So this would be the direction of the weight acting. 45 right angle. This also will be 45 degree. You can try this question. Try it.
Trying so.
Yeah. You are telling that you want to resolve the component of the vectors and do it. Yeah, that can also, that is the best way. Try it. Weight will be downwards. No, I have to draw the picture like this only. If I draw it like this, here the weight is acting in one direction. Here it would be on the, you have to draw the picture that is given.
So
Done.
not done, sir. Just like
Hmm.
I drew the picture.
Hmm.
So normal picture like mg is going downward.
Okay. I
And
mean, did
then
you draw it like this, the way it was given?
yes, sir.
That means mg is going this way, right?
Yes, sir.
Okay.
Then electric field is going towards the right.
This way. Very good. There is the
So
force.
yes, sir.
Okay.
And then tension of the string, sir.
Yeah, very good. That is the thing. The strings tension. Yeah, it would be
Then we have to resolve the tension of the string.
Tension would be along this direction.
So we have to dissolve it, I think. 45-degree
No, no.
sine and
But
cos.
what is actually the direction of the tension towards
Oh,
the paper, or I mean towards the sheet or away?
so I think so towards the sheet.
Yeah, definitely. It is. It will always be pointing that direction. So if this is 45, you are right. So if you join this thing, it would be a right angle triangle. 45 plus 90, 135. Remaining angle is also 45. So, and the funny thing is that cos 45 and sin 45 are having the
Yes,
same
sir.
value, isn't it? Length is L, but usually this is better to take as the cos component because parallel line and transversal. Yeah, very good. Now go ahead. So what we have now, you can compare that t cos 45. Don't worry, t will just eliminate. I told you in physics you have to be selfish at times. Whenever you are done with using something, dispose it if not necessary. So t we have called for, and what is t sine 45 degree equal to? Q into
Cos
E. What is E? Sigma by
electric.
2 epsilon. Yeah, the electric field. And for this case it is sigma by 2 epsilon 0. Divide the two equations. So if we divide, see, you got the main idea. You got the main idea that you have to resolve the vectors. Get rid of this. So tan 45 equals tan 45 is equal to 1. So how much is sigma? 2 epsilon naught mg by q.
So yes, sir. Option C is
Yeah. So see, you all can solve it. You have to be you have to practice a lot. See, in physics there is another trick to solve questions which apparently looks like impossible to be solved if all the four options have different dimensions. Like you can see here, all the four options have the same dimension. What are the options? Option A is mg epsilon by q. Option B is just root 2 times of that. Option C is twice of that. Option D is 1 by root 2 times of that. Instead of this, if the options were like this, this was the correct option. Then what you would have done, you wouldn't have done the numerical problem like that. You would have you should have tried to find the dimension of each and every quantity given. What is the unit of sigma? Coulomb per meter square, charge by area,
yes, sir.
isn't it? So if all the four options are having different dimensions, then, and you know what your answer is supposed to be. I mean, what physical quantity it is. Like here it was given,
So number B.
it was asked that what would be the charge for this. Yes,
Number B is the correct one, sir.
yeah, but not by doing the entire problem, just by doing the dimensional analysis like this. See, root 2 is a number, it doesn't have any dimension. So what is the dimension of this? Mass. What is the dimension of this charge? Okay, you can call it q, separate dimension. G is what? Acceleration due to gravity. That is its acceleration. What is epsilon 0? It has a dangerous dimension. However, you can find that as well. So you have to see ultimately if you're getting dimension like this or not. Got it? That is another trick.
So
Got it? Okay, I think you should leave. If do you have the next class? Do you have the next period after this?
No, sir. Fine.
Okay. Okay, we are done more or less. If you have any doubt or if you want to solve anything else, you can.
Thank you, sir.
Okay, thank you. So
thank you, sir.
unknowingly, you all use the fact that the field lines are uniform. And remember, for this infinitely plane sheet, the field is constant everywhere. It's a constant quantity. Okay. Okay, thank you then. So let's meet after Diwali, right?
Oh,
Tomorrow we don't have class. Have you checked your
yes, sir.
handbook, the digital handbook?
There's no. Yes, sir.
Do you have class tomorrow?
No, sir. We don't have, sir.
So
If you want, I can take class, but you have to bear with that sound of crackers and etc. around.
Sir,
Even though they are
crackers are
banned,
Yes,
banned,
sir.
no?
many things are banned, Uddanil. Only the 500 and 1000 rupees notes have come with that. They have only avoided by that ban. When I was a third year student in college, I even wrote an article in the paper, Uttar Bongo Sambad, just condemning the use of these things, crackers. It was published. But who cares? Next day, I used to get some threat when I went to the college that you are behaving like a very, I mean, you're a ideal citizen of our country. Just be honest. Tell me, have you ever burnt any cracker or not? I never did. I'm very afraid of burning them, to be honest. Okay. So, okay, if you want to do the class,